All right. Well, today it was supposed to be a lab day, but excuse me. Oh, that was rude. Sorry about that, guys. Today was supposed to be a lab day, but and I'm lucky. I'm glad I did. You guys are missing some information before we dove into the art of or the skill of subnetting. Okay. So I have to provide some information to you guys, some context, um, some definitions of things before we dive into it. Okay. Um, and again, thank God I looked at a couple of RFCs, aka requests for comments. You know what RFCs are. You guys will learn in the future, of course, on your own time. You can Google it. Wikipedia will tell you. You know, it's just a publication. You know that talks about technical development and standards that are set right by the IETF, right? IEEE, right? One of those two. And again, the people who create these RFCs, right? They're engineers, they're past engineers, they're actually scientists who are creating like this document, right? Of what a technology is, how it works, the research, innovations, everything, right? So just keep that in mind, right? Whenever you guys hear RFC and you'll hear this, just know, oh, okay, it's actually a you know, a documentation that's actually, on the internet that I can look up that's specific to maybe OSPF, maybe spanning tree, right? Maybe LACP. Okay. All right. So where we last left off, we were talking about subnetting, right? Slicing things up, right? Um, for things to be considered. But we need to go ahead and take a quick little technical break and explain some definition theories so it can all make sense. Okay. I saw that the chapter, I do disagree with how some of the layout is. So I needed to show this to you first before we dove right in. Okay. So let's talk about class of IP addresses. Okay. All right. So we got 5 classes. We got class A, class B, class C, class D, and class E. All right. If we're looking at this table, right, the first octet value, right, to be considered a class A IP address, it's going to have a value between 0 and 127, okay? And it's going to have a subnet mask of 8. So that is your class A IP addresses. First octet, 0 through 127, subnet mask of 8. All right? So, right, so because the network is only worried about the first 8, right? The first 8 binary bits, right, in that IP address portion of the IP address, not the subnet mask. Okay. And I'll show you how that looks in a minute. Okay. Class B, right? So class B considers, right, it's considered an IP address if it has the first octet value between 128 and through 191. I apologize, right? It has a subnet mask of 16. Okay. All right. Class C, 192 through 223. Okay. Subnet mask of 24. Right. It's 24 bits. Okay. We also have a class D and a class E, right? So class D, you guys will see that, right? You guys will learn about OSPF, right? It's going to have 224 through 239. Okay. Class E is going to be 240 through 255. Okay. All right. All right. So stay with me here, guys, right? So there is an RFC called RFC 1918. Okay. RFC 1918 actually defines private IP addressing, right? So private IPs, right? What are private IPs? These are IP addresses that can be assigned to host within a local area network, not a wide area network. Okay. All right. So RFC 1918, it defines a class A, right, to be a /8, right? So it's 10.0.0.0 to 10.255.255.255.255. Okay. So it's a /8, right? So the first octet is going to be the same, right, until it's exhausted out. Okay. Class B, right? It has a CIDR notation of a /12, right? That IP address scheme is from 172.16.0.0 to 172.31.255.255. Okay. And as you can see, the subnet mask changed, right? So it's 255.240. Okay. Class C, right? It is a slash, and this is for private IP addressing now. It is a /16, right? It could be 192.168.0.0, right? All the way to 192.168.255.255. Okay. This is just private IP addressing, right? Regular IP addressing or public IP addressing is going to reference it different, right? But I don't need you guys to worry about this too much, okay? You guys won't be so much quizzed on RFCs or actual technical documents, okay? All right, let's talk about the breakdown of an IP address, okay? So we have an IP address, right? Decimal to binary, binary to decimal, okay? So 10.0.0.1, right? So if we're looking at this, right, we see the conversion, right? There are 8 numbers between each dot, right? It's either a 1 or a 0, right? And so how binary works, right? If we see a 0, it means that bit is turned off. If we see a 1, that bit is turned on, okay? Right? And so what does it mean if it's turned on or what have you, right? It means it is being used, right? And we need to go ahead and define maybe a decimal value or hex value by binary, right? And so as we can see, right, if we go ahead and look at the first octet, right, a 10, right, 0.0.0.0.1010, right, for the first octet converts to 10, okay? All right. All right, we're still with the same IP address, right? If we go to 0.0, we see it's all zeros. Okay. All right. But if we go ahead and go to the last octet, all right, and it's a 1 as far as a decimal, right? If we convert that to binary, we see 0.0.0.0.0.0.01. Okay. All right. This is where it's going to get tricky. I'm going to try my best to explain it. If it doesn't make sense, I will send you guys videos, right? Like I was stating, bits represent, right, ones and zeros, right? 0 lets you know, right, if a bit is turned on or being in use. A 0 identifies it as being not in use, right? Okay, all right. If it is a 1, because there'll only be 2 values in binary, it could be either 0 or 1. If it's 1, that means the bit is turned on and it is being used, right? To maybe define maybe a decimal number or what have you in binary, okay? So with the subnet mask, it works a little different, right? If a subnet mask comes right after an IP address, okay? It actually tells routers, right, what portion is the network address of an IP address and what portion is the host version of an IP address. Okay. So if we're looking at this address, right, 10.0.0.1, all right, you can say it's a class A address. Okay. And so with this being a class A address, we know that it's a class A address by definition. So we can go ahead, right, and what the subnet mask is going to do in binary, it's going to turn all the zeros into ones, okay, which gives it a value of 255, okay? And that means this is a /8 address. Why do I say /8? Because there's 8 bits in use, okay? There's 8 bits that define the network portion of an IP address, okay? If my IP address was 10.0.0.10, it's still, the subnet mask is still going to be 255.0.0.0, right? There's 8 bits that's reserved for the network portion, right? And there's 24 bits set for the host portion, right? Right? 4 decimals, right? They equal, of course, 8 bits in each octet, right? The total number is 32. Okay. All right. Does that make sense? Did I explain it well? Does any questions? Subnetting is pretty hard stuff. Okay, I'll take silence as a no. All right, let's keep going. All right. So same thing, of course, what I went over, right? If we're looking at 10.50.120.7, right? This is a class A address, right? The first number, 10, represents the network part, while the remainder of the address represents the host part, 50.120.7. This means that in order for devices to be on the same network, the first number of the IP addresses has to be the same for both devices, right? So that says that they're in the same broadcast domain, right? In this case, right, a device with an IP address of 10.47.8.4 is on the same network as the device with the IP address listed above. Because again, it's a /8. All right. The device with the IP address 11.5.4.3 is not on the same network because the first number of the IP address is different, right? So again, class A, right? That 10 is never going to change. If it's something else, it's not a private IP address. Okay? All right. Here's another example, right? 172.16.55.13, right? This is a class B address by definition. First two numbers, 192.16, represent the network part, while the remainder of the address represents the host part, 55 and 13. A device with the IP address of 172.16.254.3 is on the same network, right? Versus, right, while a device with the IP address of 172.55.54.74 is not. Okay. All right. And that's just an example. Okay. All right. Perfect. Right. So this is cited notation, right? And we're going to talk about the different classes and how they identify in CIDR notation, right? The classiful, right? There's classless and classiful. We'll go about that later. Classful subnet mask, right? Which defines class A, is a /8, right? Possible for 16,777,216 IP addresses, right? So 2 to the power of 24, right? You can assign that many host addresses to hosts, right? PCs, printers, what have you, right? Class B, right? /16, right? The amount of host addresses you can potentially have is 65,536. Okay. Class C, right? Crowd favorite, my favorite. If you have a small network, it's going to be a /24, right? It only has 256 addresses available that you can assign to hosts, right? So you got your class A, class B, class C. Class A is your biggest, class B, second biggest, right? Class C is your smallest. Okay. So just like I told you, right, guys? This is how a packet looks, but take out the subnet part. This is how that looks, right? Conceptually, right? You get your network is, identifies, has one part of the IP address, and your host takes care of the other. Okay. All right. So I wanted to give you guys, again, kept it short and sweet, didn't want to go too long. I wanted to give you guys that background because I feel like lab day was going to be difficult if we did not slow it down because I want to do some practice identification with you guys, actually a 2-part lab day. Okay. So I'll go ahead and end it here and you guys have a great day.